My name is Andrey, and today we will talk about WebAssembly. And I'm from Bulgaria, from Sofia. This is a very beautiful city. Come to visit. It's very good. I work in WebPros company. Maybe you didn't hear too much about us, but I bet you use some of our projects. It's cPanel, Plesk, WHMCS, and some more. I do a scary amount of time. I do web development. I did front-end, back-end. I love the web, and I love cool technologies. And we worked in a team that deployed WebAssembly to the production. And I want to start from hottest news of this season. Late September, Adobe stated that they finished the porting Photoshop to the web using WebAssembly. This is an article of ADS Money. There he explains what should be done to do that. And this journey took about 3 years for Adobe. Photoshop is a pretty big application. And this migration needs close communication with browser vendors to implement some parts of WebAssembly, and it will help all developers now. And the funny thing, I worked in a team that has similar task, but of course in the very smaller scale. We had a TV broadcasting service, and we had a problem with popular broadcasting. So many clients easily overload the server. And we think, what if we do peer-to-peer network where every client could share the video pieces to each other? So this software could work only if it will run on many types of hardware and many platforms. And so we use it not so simple language, C++, but it could be very close cross-platform. And the application will be was big. It's 900 classes. And the architecture looks like this in the bird's eye view. It was a proxy server, could take data from the broadcasting server via HTTP and from the peer-to-peer network. And it sends data to the player, to the user, and injects it into the peer-to-peer network. And inside the proxy, there is a smart cache that do all the magic behind. So we use it C++. We compile it to different platforms. And with the browser was some troubles because there was technologies possible that allows to compile C++ to browser, but all they discontinued. And the new hope was the WebAssembly. Who does not know what WebAssembly is? Please raise your hand. Okay. I will quickly explain. This is technology that that allows you to take native application code, compile it special way, and run into the browser. Speaking about browser support, it's very broad from 2017, so it's not a problem. Every major browser today supports this technology. So our goal was to port C++ application to the browser, and the thing we wanted to make that the core code will be untouched. So we will have only single code base. To do that, there is a compiler called mscripton. And first our thought was, okay, we will just compile and it will work out. What could go wrong? Actually, we faced many problems. I have no time to explain everything, but I want to focus on the main idea. What should you do to port your application to the browser with WebAssembly? And first thing, you should understand that WebAssembly runs inside the browser's sandbox. So it could not do things that JavaScript does not can. In C++, you have easy access to file system, networking, even random numbers. And in the JavaScript, in the WebAssembly, you should replace those native modules to the implementation using browser APIs. To do that, you should implement, define the interface in this, on this edge. So one implementation will be native for native platforms, and other will be JavaScript implementation to work with WebAssembly in the browser. You should find these places easily. There the code runs to the native platform. And we should somehow link these two worlds, JavaScript and C++. The mscripting has three ways to do that. Call and crap functions. You could easily run it for C code, but it doesn't support C++ code. Another possibility is WebIDL binder. It supports C++ function, but it is another special language. We did not choose it because there is Embind. It uses the C++ templates, so we could reuse all our development pipeline, our IDE, and it has a better interoperability with JavaScript and C++. It has many features. It can do many things, and the main thing we need is to implement C++ interface using the JavaScript object. So we have a C++ core. It knows about some interface, but the implementation will be in JavaScript. I should warn you, I have a C++ on slides, but don't be afraid. We will manage it. So we see some pretty simple HTTP client. It has only get method, and it gets the address as a string and produces the string with output. To make the implementation of this interface in JavaScript, we should run this ugly wrapper, but it's a simple enumeration of your public methods. The blue color is the name in C++ code, and the green color names is the JavaScript side. Then we write this binding declaration. It works like Lego blocks. So we have a class. It has one method, one function, and we are allowed to inherit from this class. And that's all. We can make a JavaScript implementation, like some get function, some HTTP request, and then we say to mscripting to connect our implementation and this C++ module. Then we get this client, and we can use it, and we can pass it to C++, and it can use it. So making this again and again, you eventually replace all native modules with JavaScript implementation. In our case, it was XML HTTP requests, WebRTC for peer-to-peer network, and HLS.js player. And eventually, we got into production. We need to replace with interface a bit like 30 classes, and about 100 classes were deleted with native network implementation. And what we got? Comparing to the native platforms, in this solution, user does not need to install anything. They practically just opens the web browser, the video starts playing, and they have no idea that some technologies work under the hood. We keep the single code base of our application, so we didn't duplicate our bugs, we didn't duplicate debugging process. And speaking of debugging, the funny thing is that some platforms could hide some bugs, but the other platform could easily show it. And this was very helpful in debugging. The deploy process is easy as you deploy the web application. So WebAssembly module is just a file. You upload it to the server, users get it, and the new application version is start working. And that gives us the very fast feedback loop. So we could catch exceptions with Sentry, for example. We could count metrics, and we, of course, could see and read the feedback of our users. So I want to end my talk with the collection of the use cases. There you could probably apply WebAssembly for your projects, and I have a kind of hobby to collect them. And first of all, not all languages have production support. C++, Rust, Go, and .NET are ready to use, especially first two. But there are languages that are interesting to follow, but they are a bit experiment for now. And this is the awesome list. There are enumerated many languages with the current state of supporting. Of course, game engines all have support of WebAssembly because the whole thing with ASM.js and WebAssembly starts from porting games to the browser. You can imagine you can process some media data inside the user browsers, for example, images or video from the webcam. You could run neural networks right inside the user's machine, not spending your resources on your servers. Libraries, for example, if you need cryptography, the first rule of cryptography, don't implement cryptography by yourself. Use the industry standard library, and you could, for example, encrypt end-to-end your data with communication of your server. Many other libraries are ported to the WebAssembly, and not only libraries. Big applications like Figma, the standard for designing web applications now, are made possible with the WebAssembly modules. They run native code inside browser to make the application work. Another example is Autodesk AutoCAD. It is a very complicated software with nearly 30 years of history and, of course, very complex business logic. To port it to the web, WebAssembly helped them to keep the core of the application and make just a new UI. And of course, I mentioned the Photoshop, also very big and old application with the heavy graphical computations. Now works in a browser like a SaaS service. Okay, this is a pretty good examples, but can we go further? Maybe you heard that modern browsers are complicated as much as an operation systems. But what if I show you the real operation systems work inside your browser? So this is a Linux kernel from Alpine Linux running unmodified in browser. You could even compile something. You could use Bash or anything. And console is not so fancy. It's simple, I guess. There is another example. This demo is from Fabrice Billard. It's a French, very productive programmer, and he wrote the tiny emulator that emulates the PC hardware inside the browser. He compiles it to the WebAssembly, and if we give this emulator the image of Windows, it could run it. It's not fast, but it's a cool demo. It's a real Windows 2000 inside the modern browser. WebAssembly is production ready. You could port the real application. It is, even for large applications, it is possible. For our team of 2 people, it took 8 months. For Adobe, it took 3 years. And tooling are good enough. It could be better, and it gets better month to month. And spoiler, the speed of applications in WebAssembly are as good optimized JavaScript code. No more, no less. And this is the end of my talk. Thank you. This core code is for this presentation. Thank you for joining. I could answer your questions if you have.
Yes, and I'll pass the mic. Awesome, Andrey. Thanks a lot. Yeah, I heard WebAssembly now also have a proposal for supporting garbage collector, so soon we'll have Java applications also running in a browser, I guess. So from your experience, what is the biggest missing feature right now in WebAssembly? Or like what is the biggest pain point for doing something in WebAssembly?
Oh, it's a good question. Yes, there are many proposals for WebAssembly that runs on their own speed. And the example with Photoshop shows us that large companies could speed up some of proposals, and every industry will get better. We did this project some time ago, and the main challenge was there were not so many practical tutorials. So it was like a trial and error approach. Of course, it is better than you have a smart compiler, just compile and it runs. Emscripten tries to do that, but it works only for small applications, maybe for games. And in real application, unfortunately, you need to do stuff like I showed. And it is a manual work. And that is the main challenge. So it's not free.
Any other questions? Okay, then I have a quick question.
Okay.
What about the bundle size, especially in comparison to JavaScript bundle?
Yeah, so when you compile to WebAssembly some application, you get the WASM file, actual binary code, and the so-called glue code. It's a piece of JavaScript that binds it to the browser, runs it. And these files could be big. In our case, it was like a couple of megabytes. The good thing that these files are, like the WebAssembly file, is easily compressed. So you could use ordinary gzip compression in browser, and it will be like 2 times smaller. As I know, the Photoshop has bundled like 200 megabytes. And it is a pretty big file, and they use service workers to cache it. So you could apply typical front-end technologies to optimization size and bundles to WebAssembly too. So it runs in browser.
Okay, thank you. Is it a quick question?
Thank you for the talk. I have just clarify, with the WebAssembly we can somehow compile even other languages, right? So
yeah.
Because you speak more about C++ applications or something. So, but I heard that there are the people using it with other languages to somehow to compile their task because, for example, they know other languages. But what you think common cases for the world?
Yeah, thank you for this question. We use it C++. For every language, you need corresponding compiler. So Emscripten is for C++ code and for C. Rust has integrated support of WebAssembly. And I think these 2 examples are most production-ready languages. Go also has integrated compiler and tiny Go compiler to make smaller bundles. And .NET has a good support. Other languages, there are many experiments with other languages. You, for example, could write TypeScript-like application in the language assembly script, and it will produce the WASM bundle. But it is like more experimental. For production ready, I name for C++, Rust, Go, and .NET. Yeah. Thank you very much.
Okay. Thank you. For more questions, please find Andrey in networking area.
Yeah.
Thank you very much again. Let's